Good day everyone. Welcome to my video physics tutorial for high school students. Today's episode is focused on applying Newton's third law of motion, the law of interaction, in analyzing a system of two bodies that are accelerating together. So just stick around, watch, and learn. The question is, boxes A and B are in contact on a horizontal frictionless surface, as shown in figure 1. Box A has mass 20.0 kg and box B has mass 5.0 kg. A horizontal force of 250 newtons is exerted on box A. Question is, what is the magnitude of the force that box A exerts on box B? We emphasize that in the situation, the horizontal surface is considered frictionless and that the two boxes, box A and box B, are directly in physical contact with each other. So the force applied, 250 newtons, is considered the net force along the horizontal acting on the system, right? Meaning the combined masses, MA and MB. And this force applied, or the horizontal net force on the system, is directed to the right. Right? So, this makes the body accelerate, all right, in the direction of the net force, which is also to the right. We say that there is no net force along the vertical. Summation of Fy is equal to 0 because the upward forces exerted by the surface on the two boxes are cancelled or balanced by the downward force of gravity on each box. So it follows that the vertical acceleration a sub y is also equal to 0. And that the horizontal acceleration a sub x, okay, is just simply the amount of force applied, FAB, divided by the combined masses, MA plus MB, in accordance with Newton's second law of motion. Well, that is 250 newtons divided by 25.0 kilogram. That gives us the magnitude of the horizontal acceleration of the system, a sub x, equal to 10 meters per second squared in two significant digits, and its direction is to the right. Each of the two boxes also has the same acceleration. Box A can be considered to be accelerating by 10 meters per second squared to the right, and box B as well is accelerating by 10 meters per second squared to the right. We recognize that the two systems, or the two bodies that make up the system, box A and box B, are both accelerating to the right by 10 meters per second squared. And this is all because of the presence of an external net force, 250 newtons. Okay? So, how does the third law, the law of interaction, applied in the situation when the system is in a state of acceleration. All right? So, we recognize that while accelerating to the right and while they are in contact with each other, we say that box A is pushing box B to the right. And such force, labeled here as F sub AB, represented by the green arrow pointing to the right, is the force exerted by box A on box B. All right? We can call it the action force, and the reaction force would be the force FBA, represented by the arrow pointing to the left, and FBA is just the force exerted by box B on box A. So these two forces are action-reaction pair of forces. They are equal in magnitude, opposite in direction, acting at the same time, but definitely acting on two different bodies. And as far as box B is concerned, we can determine the force or the magnitude of the force F sub AB. All right, the fact that that is the only force, horizontal force, acting on box B. So we can just use the second law to get the amount of that force. We just multiply the mass of box B, MB, and the acceleration A. That is 5.0 kilogram times 10 meters per second squared. So the amount of force FAB is equal to 50 newtons with two significant digits. And that is our answer to the question. The force that box A exerts on box B while they are accelerating together to the right. All right? And by virtue of the third law, the reaction force F sub BA, all right, is also equal to 50 newtons, but in the opposite, or directed in the opposite direction. So, you see how we are able to apply both the second law and the third law in answering our question. So, just to check if indeed box A also has the same acceleration as what earlier calculated, 10 meters per second squared. Okay, let's analyze the case of box A when we treat it as a single body. All right. So as a single body, we say that the net force acting on box A is just the vector sum of the horizontal forces. The one that is exerted to the right, the applied force, 250 newtons, plus the force exerted by box B on box A, 50 newtons, but directed to the left. All right? So that makes a net force equal to 200 newtons. And if we divide that by the mass of box A, 20.0 kilogram, we have the value for the acceleration of box A equal to 10 meters per second squared. Indeed, box A and box B have the same acceleration. All right? That means we are able to check our answer. And that completes, okay, our tutorial for this episode. Till the next video tutorial, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.